Here we are going to run the code fashion MNIST image classification using KNN. So the first thing, note, I didn't wrote this code. I just got this code from some internet sources. So you can give a credit to the real author who wrote this code. So I'm just going to explain this code for you. So explain and run this code, and you can understand better. You can get a better understanding of this code and how it's run, and we'll try to solve the error if we receive any error. So we have I have this PDF file. I got it from some from internet, so I downloaded it for you to. So here, so MNIST image classification using KNN, like the fashion MNIST. You can see here is the data like the fashion MNIST. So we have number of classes and 10 number of classes and the number of sample for fashion classification. So we are going to solve this problem with K nearest neighbor algorithm, like machine learning algorithm rather than a deep learning. So I'm going to run this code step by step, and we will see what kind of outcome we will receive, and I will share this code with you. You can also perform your experiment and try to understand in a better way. So here I have few things in my laptop, so I'm going to delete this one. You can see the fashion dataset, CSV dataset, like in if you can see this dataset. So we have a fashion training dataset and we have fashion test dataset. When we open this one, you can see this dataset. So let me open this one again. Yes, if you can see here, so fashion MNIST training dataset, the file is too big, so it took a while loading here. So you can see here, so we have a dataset with uh, pixel value labels. There are the labels, there are the pixel value, like information for the dataset pixel value, because we have the image dataset. So the pixel value in the form of CSV format, so it goes up to like a, if we can check it here, there's a lot of pixel value up to 784, like the MNIST digit classification. So it's our 28 by 28 data set. So here we are going to run. If I'm just gonna make a notebook file here. So the notebook file with the name of, just copy this name from here, and we will have a name with MNIST. So here is the name of this file, and then I'm just gonna copy this first of all we're going to call import the libraries here. So I'm going to paste it here. So when I run this one, these are the necessary libraries that helps to build a model and everything. So you can see I got an error, no module name cboard. So usually I'll try to install the package. So let me see, is it, yeah, if you can see when I have installed that package. So now we have, I'm just gonna, so we have this library. I'm just gonna commit this line. So when I run this again, so you can see here it will run. So after that I'm going to call the data set. So here I'm going to call the dataset. The dataset name is here, but the data is under my directory, like the current directory where I have keep my notebook file. So here you can see the notebook file is under here. So here is a notebook file, the dataset is also here. So what I need to do, just write dot current directory and then the dataset name. So let me check the dataset name is fashion hyphen then MNIST underscore trend. So when I run this one, so header, it will show you the five uh, values, five rows, 0 to 4, like 5 rows, and the number of columns are 784 from starting from here, and the pixel are 784, but the total columns are 785. So after that, what we're gonna do, we're just gonna check some information like the same, the data types of the data frame. So here you can see the codes we have, column 8, and the labels to be pixel 784, labels to pixel. So labels to pixel mean we have the labels and the pixels value, it's giving us the memory usage, and the other entries, total number of entries for training data set. We have 60,000 starting from 0 to 5999, 0 to 599 rows. So after that, what we're gonna do, we're gonna check the null values, if either we have a null values in a data or not. So when I run this one, it says that there is no null value available on this data set. We have data without a null values. So then we can compute the duplicate number of images. When I run this, go check the number of duplicate images. So it will gonna check the number of duplicate images. We have 43 duplicate images in this data set. So after that, I'm just gonna run this cell. So it will tell us about that. If you see that np.drop duplicate, so we will gonna drop these lines and np.shape, and after that, it's mean that it will remove the number of subject, and we will have left this number of subject. Previously we have that number of subject, and then we have here, and the shape is 785. Obviously it's including the label, so we have 785 shape. 784 means the images size like 28 by 28, and the other are one is for label. So that's why it's showing us 785. So after that, target variable. So here, so the unique target value, we are going to look how many target variable like the label we have. So the unique target variable, if you count 1 2 3 4 5 6 7 8 9 10, we have 10 target variable starting from 0 to 9, like 10 number of classes. Target variable means 10 number of classes. So here we can analyze the data about that, like how many percentage I like data belong to. So when I'm trying to copy this one, so it is not moving, but I'll gonna index, let me run this one. So when I run this code, it will give us the classes, like we have a 10 classes, and the distribution is equal, like 10% of the distribution of each class. So it started from here to the 9 class. So after that, we will gonna run the next line here. So data pre-processing and making a pipeline. So the data pre-processing is because if we are going to give a data to our machine learning or deep learning model, we need to do some pre-processing stuff. So that's why, so the data pre-processing is really important. If we are going to build any kind of model, they require some like they require a data set in some format. So before that, we are again importing some necessary libraries to build our model, like min max scaling for data pre-processing, and cross validation if we are going to use a cross validation for training a model, and then k nearest neighbor classifier by using sklearn library. It's come with a under the library of sklearn. So here, first of all, creating an x and y variable. So the x and y variable, if we are creating an x and y variable, if you can see here, x dot drop label. If we are creating x variable will be over training, and y variable will be over x variable is over training data set with the number of subject, like data like pixel values. If I'm going to show you like these pixel values, and y are the corresponding label. If you can see here, the first line we are dropping, because x variable we just need pixels value, so that's why we are dropping the labels here, and the second we are just calling df dot label this column as a label. So it will store the value for x into here, and the y, the feature into here, and the y, the labels corresponding to here. The axis is equal to 1. It's mean that we are dropping axis is equal to, this is called 0, and x is equal to 1, like the column we are trying to drop. So when I run this one, so you can see also when I call this one, we have like capital, we have just only pixel values. When I run the y1, so we can see that we have the y small letter, we have the values of labels here. So the next step is to normalize. So there is a lot of method available: z-score normalization, min max scaling, another method that you can use to normalize the data. In this we are initializing normalization object with min max scaling. So after that we are going to build a model and call here. So you can see here, so I'm just going to copy this one and try to explain with you. So here is the model. So when we done the min max, we first pre-processing pipeline is like split the data into two, x and y, x for the feature and y for the test. So normalization, min max, apply the min max normalization, and after that, so you can see here training error rate and test error. We created two list and run the loop over it. So if you can see here, we are running the loop for each, like k is equal to in range of 1 and to 31. So here we are running the k loop for 1 to the range of 31 and creating a k nearest neighbor. So it's up to you if you increase the number. So sequence of operation to be performed, like here operation is equal to we are performing the operation on normalization here. So you can see here the normalization here. So after that, so k means basically k nearest neighbor. So the range, the k range, we are starting from 1 to 31, like we are trying to create the 31 k nearest neighbor. So after that, the pipeline is equal to, the use of pipeline is equal to this method steps dot operation. These are a sequence of operation to be performed. These operation that we are going to perform using k nearest neighbor on this normalized data set. And then we have the k nearest, that here it's calling the k value from this take the loop is up to 31. It's taking from starting from 1 2 3 up, goes up to 31. So calling 1k as a k nearest neighbor, and here is our algorithm apply on the 1k, then 2 and 3, and these are the operation like on these up or the operation that perform on the data set that we have. And then pipeline step operation, we're passing to the create a pipeline, and after creating a pipeline, so you can see here performing 5k fold cross validation, c is equal to 5, and scoring, we are trying to score the accuracy. So here we can see here, so we calling the cross validation, so we are using the 5k fold cross validation. You can increase and it's up to you, 5 10 8, how much fold you require for the data set. And then we are appending our rate into the list. Here we have described it training and test list. So the training score, the mean score, we are appending on this list, and the test score we are appending here. So when I run this code, so you can see here it will take some time and running up to 31 epochs, and we'll save the data here. So we're gonna see after that here. So, and then we will try to show the accuracy there. So we can see the list, how much values we have appended here, and it will show you. So it will take us some time here to run the whole uh, uh, loop up to 31. So the next step here, you can see we can also print these things like accuracy, and accuracy for training and accuracy for test from the list. So I'm going to pause this video and to save some time. So we'll see the result after it complete this after it complete to run this cell. So I'm still running this code. I just move my data set on Google Colab, but there is a lot of sample in it. So if you can see here, so there is more than like near to uh, 6,000 sample, 60,000 sample. That's where it is taking too long time. So for the sake of understanding, what I'm gonna do, I'm just taking some sample and try to run up to there. like I'm just gonna take only 500 sample from that data set, and will train the model k nearest neighbor on only for 500 samples. You can run it for the whole data set, but it need a lot of time. So here is a 500, and after that, oh, I'll make a two new variable, and so just move this cell above double x, that if you can see here. So I'm just taking 500 sample with a size of 784, and then normalize, and then I'm just going to change this to double x and double y and run. So when I run this code, you will see that it will take a while, and after that you can see here we have training error rate up to mean value of training error rate for this sample up to 31k nearest neighbor. So you can see here, we can also see for test data. So here are the sample, and after that I'm just gonna call each sample and try to get an accuracy, because each sample I'm gonna minus it from 1 minus that number, and we will get an accuracy value. So after that, when we do this thing, so we are going to see the error rate using the graph elbow. So if we run this cell, so you can see here for this one the graph elbow looks like this. So that tell us which, like if you see which, in which one, like error rate, what is the error rate. So you can see at the 5, you can see the error rate when the k value was 5, the error rate was quite minimum. When the k value was the error rate was maximum. So you can guess an idea, and then you can uh, normalize your data something. So here the error rate was -4. So with the help of graph elbow, we will get an idea about that. So to the 31, where we find the minimum error rate. So then what we were gonna do, the final k nearest neighbor model. So after that we will decide to develop our final k nearest model, like on the base of, then we will get a elbow graph. So our elbow graph give us like the 5 value. On the 5 k value, we get the minimum loss error rate. So the simple method is, so rather than we will gonna call the, what will the maximum, our k value will be 5 here in this case. So we are going to use the k value is equal to 5. So after that we will gonna run normalize the data set again using the normalize fit method to transfer or transform our data set by using this method normalize dot this one that comes with our package. So just if you can, we will see that normalize, and where the normalize comes. So this is normalize dot fit transform. So when I run this one, it should call for normalization function. So after that, what I'm gonna do, so here is so we can fit the data set to the model with a label of 4. We can see that here is the KNN dot fit x normalization and y. So here is we will get some error. So yeah, the thing is that we convert our data set. So I'm sorry here, so we'll have to use this one, not that one. So here is we can use this, and then that one. So k nearest neighbor classification, this function comes in normalize. So the normalize is basically we called in the previously, yeah, normalize dot min max scaling. Here is that it's calling fit transformation by using that method. So after that, so I'm just gonna we'll just gonna predict the results by using and KNN dot predict with this data set. Here is the results of the prediction, and then we are going to draw a accuracy graph here. So the confusion matrix that will help to understand the results in a more better way. So here is the confusion matrix. I'm just gonna copy this code and paste it over there, and we will see how it will show the results. So here is the confusion matrix graph using the heat map. I'm just calling this method confusion matrix and passing y and y prediction, y the data set that we have. In our case, the data set it is double y, not the y, and the predicted y is here, that comes from here. So when I run this one, so you can see here our result for 10 classes starting from 0 to 9 and 0 to 9. Here are the results. The actual result, total number of sample were, like if you add this one, and 50 were accurate classify and the others are misclassified to the other classes for 0. So the next is, so yeah, that's it. If you, we can also call this method to print out the classification report. That's this method to print a classification report for our uh, actual label versus the predicted label. So precision, recall, and upfront score and sport. So micro average and weighted average. Here is the final results for that one. And we can also test our accuracy by using test dataset, but here I'm not gonna use this one. So for that one, I'm not gonna use this one. If you can see y predict, so we'll check the accuracy over here. We're getting 80% accuracy. So I'm not gonna go use this one because we have a lot of samples over here also. So let's try. You can also check it if you want. So here is the prediction results. Let's try it. I'm just gonna copy this one and see that what kind of result we are getting in our uh, this data set. So we know that here is our data set. When I run this cell, so here is that, and the information about the test data set. So we can see the information about the test data set, like number of integer 10,000 starting from 0 to 19999. So we can check there is a null value. We know that there is no null value. Just copy and paste that, and after that we split the data set for training and test, and we will gonna use, here is training and test. We will gonna use the training data set, normalize the data set according to that we already normalize for training. So the test we also need to normalize to fit the data set to the model for prediction. And here is the prediction. Hope it will not take a time because we just only trying to predict the data set. So you can see the prediction results are here, and after that we will check the accuracy for on the prediction. And I'm not sure it will be good because we have used a less number of sample, but yeah, the results are bit good, like not too bad. So we can also generate this report for, yeah, here. And then the final, we can also check the accuracy, how much accuracy we obtain on 10,000 numbers. So we have obtained 72% test accuracy on unseen data set. That is pretty awesome because we just only have trained the model for uh, 500 subject. So we are getting a good accuracy. You can train the model for whole subject and you will get a more better accuracy. So you can see I'm still running this one. It's taking a long time. So that's why I just took some sample and trained the model for 500 sample to give an understanding to you to. So thank you so much for watching this video. So you can find these things in my blog, and also you can get it this data set these things on my GitHub link. I'll just gonna upload on my blog here, and I will also upload these things on my GitHub. So here is my GitHub link, so you can find it from here and my blog. And so thank you so much for watching this video.